All right, so next thing we're going to talk about in Chapter 5 is talking about congruent polygons. We're going to spend most of the chapter talking about triangles and different ways to prove triangles congruent, but polygons in general. And we just finished a chapter with transformations talking about when we have any type of polygon of whatever size or segment for that matter, we can keep it the same size and shape when we are just transforming it by sliding it, flipping it, turning it all over the diagram, and it's congruent when that size and that shape does not change. And when that happens, that means that we have all pairs of corresponding parts are congruent. So when you have congruent polygons, we're talking about all corresponding sides are congruent, and all corresponding angles are congruent. And when we say corresponding, we're talking about in corresponding locations. So if I were to say that quadrilateral ABCD is congruent to quadrilateral EFGH, the order in which I list these is important. So I am saying that A is equal to E, and B is equal to F, and segment CD is equal to segment GH. So the order, when we're talking about corresponding, which of them are in corresponding locations? So looking at these two triangles, the diagram is something we can mark to be congruent. So we could say that R and A would have to be congruent. We could say that S and B have to be congruent, and then we could mark that T and C are congruent. And so we can use that to label the sides and the angles which are congruent. So why don't you pause this and take like 30 seconds and answer these 6 questions. So we should get that angle C is congruent to angle T, angle R is congruent to angle A, segment AC is congruent to RT. And again, you can look in the diagram for these. You can even just look up here in the order in which they are listed. So ST is the last 2 letters up here, so it's got to be congruent to segment BC, RS and AB, and then angle B is congruent to angle S. So now this one is going to go in the opposite direction. So we have all of the congruent marks. Which triangles are going to have to be congruent? Now, the first triangle, you can list it in whatever order you want. So if I even didn't want to list it in alphabetical order, I wanted to say that triangle BAC is congruent to which triangle? And this first triangle doesn't matter the order. But when I list the second triangle, it has to match up. So if I say angle B is first, I have to match that up with which angle is congruent to angle B, which is angle E. And then looking at A, so that matches up with angle D. And then C and F match up. And then I could do the same thing in this one. So let's go with triangle ABC is congruent to triangle, and so I need to find what matches up with A, which is E. B matches up with D, and then it would be C. So we could do this by listing the triangles that are congruent. We could also use this to find angle measures or X and Y values based on side lengths. So first, why don't you take a moment and based off of this information and see if you can get an equation that tells you what this is equal to and 3x plus 2y and what x minus 2 is equal to. So 3x plus 2y is angle P, which I can see from here with angle P. It matches up with angle G. So I know that 3x plus 2y has to equal 84. I then see that x minus 2 is marked for MQ, and MQ is the first 2 letters, so it has to match up with DE, which is 8. So the second equation is the one I need to solve first, and I get x equals 10, and I can plug that into the top one. and get y is 27. And then the last thing, it kind of depends on where you look. Some of the resources we've used, we'll be able to use, go through it as the no choice theorem. And then the current book uses it as the third angle theorem. And which you can call it whatever theorem, it's not really important. But what this is really going through is if we look at these two triangles, if we know that angles A, B, and C have to add up to 180 degrees, because those are our rules of a triangle. And we also know that angles D, E, and F have to add up to 180 degrees because all triangles add up to 180. And we know that A and B are equal to E and D. So we know these are the same. We are always going to be left with the exact same number for the last third angle. So the no choice or the third angle theorem is stating that if two angles of a triangle are congruent to two corresponding angles of another triangle, then the third pair of angles must also be congruent. So for example, in this one, and obviously you can mark it in the other one because we can see that A and R are going to be congruent, but we could solve this one by subtracting 74 and 41 from 180 and get that angle C is 65 degrees. And because these two angles are congruent, A and B, to angles R and S, T and C must also be congruent, which means angle T equals 65 degrees. And so that will conclude for congruent polygons, and then we'll talk about how to prove different polygons are congruent, specifically triangles, as we move forward.